it's live? Oh, we are live. I don't know, is it working? Can anybody go to YouTube and look for Eugene Tech and see if we're streaming? I'm gonna have to put a new key in here. Oh, it looks like we're streaming. All right, cool. All right, thanks. Okay, cool. This is Augmented Reality in the Modern Browser. Antonio Ortega is here to tell us all about it.
Let's see. Okay, yeah, mic works. Everybody can hear me. I'm sure everybody on YouTube can hear me now. And yeah, augmented reality in the modern browser. So let's just get started. First up, I'm Antonio. I work over at IDX Broker downtown here in Eugene. I also run the Eugene Web Devs Meetup, which happen the last Thursday of every month. And we usually just do topics on anything web dev from the front end to server side. Oh, yeah, you can turn the volume down on that. That's fine. So you can find out the next meetups we have there. I also read a lot of comic books. That has nothing to do with the talk. I just tell people that. So, augmented reality. This is a technology that superimposes computer-generated images over a user's view, then providing a composite view to the user. So normal reality here is the base. So a camera is a good example, but really any part of reality, your geolocation, like where you are in real time or real locations. That's a part of reality. You're really there. That can be the base as well. I suppose you could even do sound. I haven't seen anybody really do a whole lot with sound to augment reality other than Philips Hue lights. When you play songs, it will listen to the song and change the lighting accordingly to kind of change the experience. And in that way, it is making decisions for you to affect reality around you, at least your perception of it. What I'm not going to be talking about is virtual reality. So everything I'm talking about is going to have some sort of anchor here in the real world. It's not going to be building your own world and going through it. That's a different talk. A lot of cool stuff there too, but it's different. So a long time ago, I think, I don't know what, 5, 10 years ago or something, we started talking about augmented reality, and everyone had ideas of what it was going to do. It was going to be this cool thing that's going to change the way we take in information, and we thought it was going to be something like this. Here we have a surgeon with some sort of device, a lens over her vision that's giving her real-time information about this patient and what looks like a problem with his a valve in his heart or something. So that's what we thought we were going to do with it, and it was going to change and improve the way we get information about things going on around us in the real world. But this is what we did. We made Pokemon Go instead. So this is what we decided was more important to do with augmented reality, was to repackage an existing game. I think it was called Ingress, which was the exact same concept, but without the cute Pokemon characters. And then 750 million people download this because that's what we decided to do with it. The other thing we've done is next level selfies. We didn't have selfies like this 10 years ago. Now we have this whole other world of selfies, and it's its own thing. We have drones for selfies, sticks, and all sorts of accessories and gadgets and whatever. But this is also AR. This is taking my face and augmenting it some way, giving me, that's augmented. That's not my eyeliner. And then the ears and stuff. So that's kind of where augmented reality is right now as far as its ubiquity, where it's all spread out. Everyone has used those. We did do some cool practical things. So I was really glad about that when I started looking for examples. This is really simple, but really useful. And all it is so to help you not hit things when you are backing up your car. This doesn't really give us a whole lot of information, but it's enough of a guide to hopefully avoid minor accidents. And it's not a huge deal, but I think it's cooler than Pokemon Go. Maybe not. We also see it in sports. So World Series just ended, and when I'm watching it, I'm getting data about this pitcher, where the pitches are going, whether they're in the strike zone or not, the speed of them, which order they came in. All of this is just being overlaid on what I'm watching already, and it's really cool. And it is a form of taking what's really happening here, the baseball game, and augmenting it with more data. We do the same thing in football. We have for some time where you can see where the line of scrimmage is and where the next 10 yards are, and what down it is. So 1st and 10. I remember when that first came out. Somebody was like, "How do they get that on the field?" And I'm like, "They don't. It's just a overlay." So we have done some practical things, and there are new practical things coming out. This IKEA app's pretty neat. You scan the room with your phone, and then you say, I want to see what this couch would look like if I placed it there, or there, or there. And obviously, it's to help boost sales. You can shop, say, "Oh, I want this couch and this color. I want to check that out in my room with the rest of my decor. How's that going to look?" And augmented reality allows you to do that without having to buy it and then move it around. So that's also more practical, and I think that's the more interesting thing for me. The games are cool. Games are fun. But I'm more interested in stuff that I can use practically. And then in this case, with IKEA, now I'm enhancing my brand because I'm making an association of this cool tech thing with my shopping experience. And that makes me want to get stuff from IKEA. And all of this mostly is done in native apps, native mobile apps. So the IKEA is in the iOS store. The baseball ones aren't, obviously, because they're on TV. But Snapchat is iOS and Android. And iOS and Google have both released AR kits for their native applications. So you can get the new AR kit as part of Xcode. It's in the new Xcode 11, I think. And then AR Core is the same thing, but from Google for Android. The other option, like in the car, is hardware. Like we have a HoloLens over here, this cool thing. I just played with it. I'd never played with it before. It's pretty neat. But it is also hardware. That's another part of overhead. Somebody has to buy this thing in order for you to use it, and this form of augmented reality. And then here's the thing we all use already, browsers. So my question for this talk was, why, if I'm already using web browsers, why can't I just develop the same thing for the web browser, since everyone has one of these in their pockets already? Not everybody has a HoloLens or some other kind of hardware that you might need for augmented reality. So you can now. The problem before, I'll get that more into that in a little bit here, but you can now. WebRTC is the real-time communication between the camera on your phone and something in the browser. So now I can stream reality to the browser, and the browser can start to do things with reality, whereas before it wasn't supported by every OS. Most specifically, iOS. So this has been around for a long time, honestly. When HTML5 came out, there's a bunch of supporting Chrome. Chrome's always the one who's like, "Oh yeah, we totally support that." And a lot of things already use it, like Skype through Facebook, Google Hangouts. They use these, but they have a plugin for the browser and other things that they do or proprietary to make those things happen. Like Skype's proprietary thing, you can't just go anywhere and do that. But web developers can use these too, just in a much more generic way that is available to everybody. And all it is JavaScript. So here's the most basic thing I could do to get a stream to the browser and how to call it in JavaScript. You set your constraints. In this case, I just want video. And then, so my first constraint is video, true. And then you just call the native API that's there and now supported by all the major browsers on mobile, which this is navigator.mediadevice.getUserMedia, my constraints arguments. Then I get the stream. I can put it onto a canvas tag. I can show it in something else. And then further on, like the augmentation comes in. But this and a canvas tag will allow you to, in the browser, show whatever the camera's seeing, and thus putting reality into the browser. Of course, you always have to ask for permission. Security is important. This only works on HTTPS. And you will be prompted every single time. Like on this one, the browser will ask the user for permission to access the camera, which is good. Security is a good thing, so I think that's fine. So which leads me to why haven't we used this already, right? If it's so easy. So adoption from iOS, only recently happened. This was, I think, at this point, a month and a half ago with iOS 11. The real-time camera, that JavaScript function, was blocked by the OS. So no matter how much Chrome supported it, or Firefox, or anything else, iOS was saying no to it. So that just put it with the popularity of iPhone, that makes it a real challenge and kind of a pain to get started developing on this stuff when you know however big a segment that is these days is just not going to be able to use it. So everyone just kind of waited on Apple. Originally, I wanted to do this talk a couple months ago when it was warmer, and I wanted to do it outside. I wanted to have all my slides in augmented reality, so everybody would just hold their phones up and look silly downtown. But it's too cold for that now. Thanks, Apple. So I'm going to be showing some examples of this, and this is going to be done like with most things in JavaScript these days, frameworks. It's either frameworks or packages, either or, somebody else's code, building on top of that. These are some of the most popular ones right now. All of these guys are patching for on their GitHub repos for the iOS 11 because their implementation is a little bit different. But these are all of these are available on GitHub and free to use. So each one of them has these requirements, though. So HTTPS, of course, JavaScript has to be enabled in the browser. If that's such an edge case, I don't know who worries about whether or not somebody disabled JavaScript because most websites aren't going to work very well without it. iOS 11 for sure for iPhone. Anything before simply won't work, and I never will. I'm sure iOS is not going to retroactively allow this for anything. Their motto is get a new phone usually. And Android all the way back to Lollipop, so pretty far back for Android. I'm not sure if it goes even further back than Lollipop. It might. I just don't have like 100 old Android devices to test on. So these are pretty safe requirements, I think. And if you want to know about a different browser, let's say Edge, which I don't have, so I haven't tested on. According to this, it works. And this is caniuse.com. And you can search for all sorts of JavaScript, this or that, and see the support as these guys keep track of it. And you can see the middle one there, Safari, before 11 is red. It doesn't work. What else is on here? Opera Mini will never support it. Android browser has for a long time. And most of these things for the other HTML5 JavaScript things are slowly getting more and more green and more accepted. That promise a long time ago that JavaScript was going to be the thing and we won't need native apps to do most things is slowly but surely making its way across all the browsers. So using reality, this is what I consider reality. Little dinosaurs. This is my reality right here. We still need that base, right? We're not making a whole new world. That would be more like VR, more like virtual entirety of reality. I just need most of reality to do something small on top of. So let's take a look at types of reality. So like I said earlier, here's one type. This is geolocation, also available in the browser via JavaScript. So again, has the same requirements, HTTPS, so ask for permission. User has to allow that for security. But with just navigator.geolocation.getCurrentPosition, I can get the latitude or longitude. Once I have that, I know where you are, and then I can make decisions of what I want to do about reality. So for example, a good example is like wayfinding, right? So you're in town and you want to go on a tour of the city's historic buildings or something like that. I know the geolocation of each one of those buildings, and if I know your geolocation, I can decide if you're close enough to see my overlays, my augmented reality, that says something about the historic building or any other information I want to provide you. The phone will actually even give you orientation, so where you're looking, up or down, and it'll give you cardinal direction, so it'll be like that's north, west. The phone knows all this stuff already and can translate that to the browser, so that way you can make your decisions on when to augment reality based on the reality point of geolocation. That was a mouthful. So notebook computers are going to probably use whatever IP they think you are closest to guess where you are. And these aren't as accurate as the geo stuff in your phone that the native applications access, but they're getting closer all the time. So If you need pinpoint, then you're probably going to have to go back to native applications. Yep, yep. The browser can know whether you're on a mobile browser or not, and often identify, I mean, in some cases even identify the phone, depending on the phone. Because it's so much more general. Oh, go ahead. So
take care of for you?
yeah.
Okay.
So the question was, it's great that you know the orientation, but you have to be good at math to figure all this stuff out, and that's true. Anytime you're dealing with geolocation, math comes into it, especially in this scenario here, where again, this would probably be good for a wayfinder. If I'm in this building, then I can have augmented reality tell some sort of thing, like a list of where all the rooms are, a list of something that's going on in the building, events in the building. You can just pull up your browser and hold it up anywhere. And as long as I'm in that geo fence, I can show it. And as soon as I leave, no harm, no foul. It's not on my phone anymore. But finding whether that point is in that polygon is just straight up math. There's nothing else to it. It's just math. So if you like math, yay. If you don't, there's probably a JavaScript library that'll help you. There usually is. So another kind of reality type is a physical marker. The phone interpreting what it's seeing to some degree. And in this case, really what all it's doing is looking for the differences, the contrast between the light and the dark here in this marker. This is a lot like QR codes, but the idea isn't that the data is embedded necessarily in the image like a QR code. So QR codes, they all interpret the same thing, and it's usually just a string or something. This just wants to be recognized. And once it's recognized, then the phone can decide what to do with it because it knows there's a marker there. You could use these in conjunction with the geolocation to have the exact same marker relay different information based on your geolocation and there being a marker. So this is an example of a vocabulary game or learning game that's what's that called? Edutainment? Is that what they call it? I think that's what it's called. You see the vultures on the V card. The penguins, I actually only wanted this slide because I like the penguin and the donkey in it. But when you look through it through the phone, you'll see an animal that corresponds to the letter that's on that card. And this is so kids can learn the alphabet and stuff and by associating with the animals. So these cards work together. I've seen games kind of like this, where card-based games, where once the cards are near each other, they can do something, whatever the game decides. But this is another way to get more content out of something that's really cheap to manufacture, right? Cards are easy. So the other reality type, this is my ugly face. This is me at home in the middle of the night testing this stuff. But that's another reality type, right? The camera. The camera sees just like our eyes do. So it's going to perceive reality the same way we do, for the most part, with a little less depth. But that's the other reality type you can stream in. And so I wanted to do some practical examples because, like I said, the games are kind of cool, but I think for some of these tasks, it's not something I'm going to do all the time. I'm going to take selfies all the time, sure. I'm going to play this game all the time, sure. But for things like wayfinding or information I just need kind of now while I'm there, I don't want to get an app. I don't want to do any of that stuff. I want a really easy way to do a quick thing. So I'm going to be looking at displaying more information than reality has. And this is my first use case here. I need to grab one of my props. The first use case is IDing something. So, we all have IDs. And in this case, Lilu here is using her multipass to show that she's herself. And in this movie, when she pulls up the multipass, they put it into this proprietary machine that goes back to the central database and pulls up the picture of her with her name and her information on it. And this is, we do stuff like that now. You go to the DMV, and they can do that there, but everybody here doesn't have access to that. We don't have this proprietary machine. We don't have access to the centralized database that they do to verify someone's identity. Be cool, maybe someday, but, and the other thing too is this is another piece of hardware. You see it's got little lights on. There's probably more of something going on with that. I think I lost my slides. There we go. And the other problem with that is it's a physical thing that can be faked. This is a website I found online and doing the research. They just make fake IDs, and they go off bragging about how good they are, how they will scan if somebody does, like California has a magnetic strip that has information, and apparently that'll work. Some of them have these bar hash things, and they are bragging that their forgeries are so good that it'll scan correctly. And even when you have some of these scan machines, they just scan to see if it's a valid ID. Again, they don't go back to that centralized database to find the truth, to find what's in there, and compare it to what you're seeing. So that's why AR. If everybody can grab their phone. And I have some of these markers around here too. And go to this URL. This will work if anybody's watching the stream. For now, I'll probably take this down at some point afterwards. So if you're not watching live right now, it's probably not going to work. And at that URL, you should be asked if it can use your phone's camera, I'm sorry, if the phone's camera is allowed to be used. And then after that, all you have to do is point the camera at this marker, or the markers around that I printed out. And the idea is that, I'm wearing this name badge that I had printed up, and it's all fine and good. And, my face matches, but anybody can print up a name badge, right? I can go down to Kinko's or whatever and print out a badge with my face on it, even though I'm not actually Antonio who works at, where am I working at? AR Inc. for whatever reason. These badges were made by my pal Matt Bliss here in town, so if you need badges, look up Matt Bliss online. Or contact me and I'll get you in contact with him. So is this working for everybody? Everybody getting you should get a copy of this badge. And then, go ahead. I'm sorry? That is an O, yes. If you're having trouble in the back, you might use one of the markers that's there on the table, because the marker might be too far away. It does go to AWS, yeah. It goes to an S3 bucket. Yep, short URL is case sensitive. So the idea is there is a central truth that everyone can access. So now, in this scenario, anyone who wants to make sure that the person wearing this badge is, in fact, the person whose picture is on here, you can look at this marker. This will go back to a website. In order for me to forge this, I now have to hack the website and change the badge that's stored over there on the website. So, and the markers can be simple. They're not really displaying much information. They're just getting recognize the difference between the dark and the light at a certain pattern, right? And that's it. So you can even do branding inside of it and stuff like that. Yeah, it might just be too far away if you're in the back. Yes, your question was, is it asking the question, is this marker in my field of view and for the camera? And yes, that's all it's doing. The marker itself isn't giving it any information. It is only saying that it is a marker and that it should be recognized. It's up to the camera's resolution that can affect it, and lighting. Lighting can really affect it. If there's like a bright light on it, usually that's fine if it's tilted and oriented in a different way, as long as it gets enough of the pattern of that big black bar, then a big white square with something else in it. So as long as it gets enough of that and recognizes a marker, it's fine. The orientation isn't the biggest deal. Like I said, the biggest deal is like a light source on it changing how much brightness is on there. The software that reads any marker isn't concerned with orientation. It's just, at some point, it matches enough to say that it's a marker. Yeah, those are tied together. It's just the JavaScript library. In this case, it is, I'll go to it. Give me a sec. I got out of there. This is ar.js that's doing this. And this is just a library, and you say, when this marker, and this marker to the JavaScript library, this marker is just like 255, 255 over and over again, and then 0 value for the white over and over again. And when that is close enough and that for that library that it sees as the camera is seeing, then it says, now pop up a marker, or pop up an image, I'm sorry, on the marker. Yes, the library has the algorithm for the close enough. So you don't actually have to do anything. And you can put different letters, you can put an image inside of it. If it gets too fancy, you might have to adjust the algorithm yourself. But for the most part, big blocky stuff's pretty easy. And like I said, these are easy to make. This would be good for like security staff. You know, anybody can get a t-shirt that says security, and if you're a big guy, probably nobody's going to question it. But if you have some sort of marker, and I can go to the event, like a venue website, and be like, nope, that's a legit security guy, because then I can see the badge that is the centralized database, that is the truth of who this person is. So that was just like a real life use case, less about games and more about security in the real world, and giving that knowledge out to anybody who goes to your website. So what we want to do also is do what apps do, but in the browser, right? So I showed earlier the next level selfies with all the stuff. That can also be done in the browser. That doesn't necessarily have to be a native application to get that kind of stuff, and it's fun and people like it. So this is another URL to type in if you want to try it out, but this is what it does. And all this is doing is the same thing. This library will look for the light and dark of your eyes. So your eyes are really white, and even the fairest of complexion is usually not as white as your eyes. So, and then again, you have the the iris and stuff. And so you have these spots where you have a lot of contrast. Everyone has a shadow right here under their lip that is going to contrast. Your nostrils, right? Those are two really dark points to the camera. And when the algorithm, again in the library, finds these things, there is yet another algorithm that's been developed that says if you find two eyes, odds are the mouth is about this far away. The nose is about, you'll expect a nose here somewhere in there too. So it goes through and tries to figure out where your face is. And it's pretty good. I ran this not shaving on purpose to see if it could find my jawline, and it finds it just fine, because the other algorithm is doing its estimation of where a face would fit in normal human proportions after running through a bunch of faces and getting developing that algorithm. So I see somebody turning the phone around, like, this library doesn't do the best at deciding whether to do the front-facing or the rear-facing camera. So sometimes that's happened. That happened at the last talk too. I didn't put any option to flip cameras or anything like that. And that didn't happen in any of my test cameras or test phones that I was testing with. It happened with one particular Android phone at the last talk when I did this, and then now here. So, so it's working for you. Anybody? If you're not human enough, I can't fix that. It's in the browser. It's not actually on the phone either. It's in the browser memory. So this doesn't always work very well, depending on what overlay you want. You have to consider that. I tried to do this with famous baseball player Rollie Fingers because I liked his mustache, and it thought this was an eye because it's kind of the right shape. It's kind of got enough white in it, and there's kind of enough dark around it, right? You can see how it fooled it. So it's definitely not perfect. Snapchat's face mapping stuff is really, really good. Even like if you have the Snapchat and you tell it to your face, you'll see how many points it's actually doing on your face. It's looking for cheekbones. It's looking for above your eyebrows. It's looking for all this stuff. And it works much better than this. But again, this is just in the browser, and I can throw it up on any web page for any service, and it should work. I see you were trying it with the ID. Is that working? Nope, browser. All in the browser. Works on local. Yep. None of this is downloaded. None of this is any of that stuff. It's just in the browser. And that's why I can do this and say just go to this URL, just like you would any other web page. If it was processing server side, I mean, it gets a little more complicated. You could probably do it too, and then serve back up the image. But the problem is you would then have to stream the face back to server side and then wait for that to come back. And that's a lot of data just to stream across. So everything just running in the browser makes it work pretty well. And this is just the one library. Again, this is just one library I brought in. CLMtracker.js, but all this stuff's on GitHub. So that's all stuff we can do in the browser right now, and it's stuff we're not doing. And this will probably happen, and we'll probably start doing more in the future. And the question is, who's going to build the AR future? And hopefully it's not this. I don't want to see this stuff happen. This is some sort of nightmare that somebody has concocted, and it is just not good. No. As long as you didn't do this, I'm totally cool with it. So why shouldn't the browser lead this kind of stuff, right? Why shouldn't the browser be the one to say, we're going to use AR in, more often and in more places without having to do any of the native stuff? The browser's already everywhere. There's no new hardware. You don't have a new development environment to deal with, like Android or iOS. There's nothing else to download. It's everything, like you said, is already in your hand or your pocket. If you're a web developer, you're already working with JavaScript. And even if you're not a web developer, you might be working with JavaScript, Node server side. JavaScript's becoming a lot more popular with hackable wearables and stuff like that. Python's still the dominating language, but JavaScript's getting more popular for those kind of things. And there's no app store to deal with. And if anybody's ever tried to put something in the Android app store, or not Android, iOS app store, it's not as easy as it could be. So one of the reasons I think we're not doing it is because of things like this. This was also with iOS 11, the AR toolkit, right? So iOS, Apple puts out this toolkit with Xcode and says you should start developing your cool AR stuff for our mobile devices. This is we are put into our store, right? And they give you this cool, like, this is a nice page. It's got a cool logo. Little things about iPhone X, because that's cool, I guess. Machine learning, that's another buzzword. But that's what they want, right? They're like, yeah, get started in this. And that's great for them. This was their release for the WebRTC being available on Safari. And it's literally this line right here. So I think their intention's pretty clear on what they want you to do. They want you to feed their store, right? They want you to make cool stuff and put it on the iOS store, not in the browser, because that doesn't enrich their store environment. It doesn't get people looking for more apps. It doesn't get all these things that are really Apple's concern. And frankly, as a web developer, not mine. The Apple prefers native. Yeah, it's not much. And Google's more open. Chrome's been supporting WebRTC for a lot longer. They kind of did make the biggest fanfare about AR Core, like Apple did about their SDK that they released. But big surprise, right? Google's more open. That's just normal. So because we don't need to do those kits or any of that stuff, like I said, it's all in the browser. It's all already there. Any web developer can make AR a normal part of your website experience, just like something like /AR for whatever you want to do. Like I said, wayfinding, if you're like a museum and you want to do AR over the labels, if you're a city and you want people to tour various statues or historic places in your city, you can do the wayfinding with geolocation, and then just go to your web browser. Most of these tasks aren't very repetitive. You're not going to do the same wayfinding every single week. If I'm going to do that, I probably want a native app because I want to do it every single week and want it on my phone. But if it's just a one-time thing and it's just convenience, I think the web browser makes more sense. So thanks. That's my talk. So does anybody have any questions? I know we already had a couple of them.
And yeah, if you got any questions and you don't mind being on the live stream, I'll pass you the mic.
No? Perfect talk?
All right, thanks.
Oh.
So the markers,
Yeah.
is it generic enough that it doesn't have to be like a piece of paper? Could you actually program a lamppost? And if you point it at a lamppost, it'll probably figure it out.
Probably, if it's a very distinct lamppost with very stark, contrasting colors. It can even be on a screen, on a TV screen. You can project it with a projector. I mean, there's a lot of different ways you can do the markers. That'd be really interesting if, using physical objects as the marker.
Right.
I think that would be really interesting.
Maybe the sign on the front of a building, like the company sign, you can hold up it and
right.
it might find
So
it.
for this library, the algorithm that it figures out is pretty simple. If you have something that's much more absolute, like a logo, like a business logo, I'm sure you can find that shape of colors inside of something. You would have to map out what color that is, value, and how many times you expect to see it. But it is totally possible. Yeah.
calling the like whatever the update function would be.
Oh, to update. So the question was, the tracking on the face recognition is a little not best.
Also
On the marker too, yeah. It gets called, I think, every second by default in both libraries. So yeah, the right angle, or especially with the marker, if there's a bright light source that's bouncing off it and making one part more light, it gets confused. The face one gets really confused when you turn your head. It starts to get confused, and it's, I'm sure you could turn that up in both libraries. I haven't.
Is there like a runtime limit for the browser where you're running up against like performance issues?
Yeah, I mean, but that's true of all JavaScript stuff running all the time, right? You're going to get support or performance issues at some point. And all this was running, if you notice, just by itself. If I'm running this in a website, I'm probably going to have a header, Google tracking, Google tracking codes firing off, a lot of other things competing for resources. So optimization on your website's probably going to have to happen.
Thank you.
Yeah. Any other questions? Okay.
Website versus app. To a certain extent, if you can put something in a browser, you can wrap it up into an app, right? So you could have
to a certain extent, sure.
the best of both worlds.
Yeah, I mean, if you're going to do that, that's fine. The thing I like about not doing a native application is I don't like dealing with the stores and their policies and all that other stuff. And I get, especially in iOS, I get constrained a lot more in different ways.
But if you can convert the web page to an app without much extra work,
You can totally just throw a web view in any native application, and it'll do the same thing.
Yeah.
So yeah, that's totally possible if you wanted to, if you found a good use case for it. I probably wouldn't. I'd probably do one or the other. Oh, jeez. I think, yeah, he's trying to get me stuck in infinity, apparently. Yeah. Any other questions? Links to all of these libraries and everything is on the Eugene Web Devs GitHub. So every time I do a talk for Eugene Web Devs, I make a GitHub repo that has as much information about the stuff that was talked about all the any links and everything to all GitHub repos used, and every example that I can get from the presenter. In my case, I was a presenter, so it's there for sure. I know I put it up there. So if you go to eugenewebdevs.com, you'll see a GitHub, and just look in the archive, and the archive will have resources from as many talks as I can find. All right? Okay. Cool.